Hello and welcome to our myth-busting video series on environmental monitoring in the data center. The purpose of this series is to look at the unforeseen risks inherent with running a data center, especially when relying solely on environmental monitoring. Many data center operators rely on trending analysis and projections to plan their deployments and maximize capacity. The idea is to use historical trends collected from their monitoring equipment to make the impact of future changes a bit less unexpected. In this video, we're examining a sample data center designed with N+1 redundancy and equipped with a full monitoring and DCIM kit. Starting at 20% of the design IT load, we're going to simulate a series of IT deployments. Throughout these deployments, we'll highlight a single IT device and its nearest cabinet sensor and compare the inflow temperature with the sensor temperature. The plot on the right shows a trending plot of how these two temperatures change with each deployment, or timeline step. During operation, the monitoring system tracks cabinet temperatures and should alert us to any increasing temperatures as we deploy. We can see that over the course of the deployments we've made, there was a spike in IT inlet temperature that was not captured by the cabinet sensor. The IT inlet temperatures seem to change with almost every deployment. By step 8, the IT inlet temperature is steadily rising with each deployment, but the cabinet sensor still reads green, so we continue with the next deployment. When we get to step 9, the IT equipment overheats. How did the monitoring system miss this? If we refer to the temperature trending plot, we can see that by the time the equipment overheats, the cabinet sensor has only just begun to notice the rising temperatures. In fact, it's underreporting IT temperature by an astounding 19.2 degrees. This all seems rather suspicious. How is it possible for this to happen? Let's rewind a bit. If we go back all the way to the first timeline step, we can run through the same deployments, only this time animate the airflow delivered to each of the device inflows. Notice how with nearly every deployment, the airflow delivery profile changes. This may be due to IT changes in the cabinet we are looking at, or changes made in other parts of the facility. The data center is a dynamic space, and every little change is going to impact the way the air moves around. At step 6, we can start to see warmer air creep in from under the cabinet. This air mixes with the cooler air delivered from the grill. By step 9, this warm stream of air has risen enough in temperature that it is now rather hot. This issue, that was left undetected by the cabinet sensor, becomes the source of the equipment overheat. Now that we are aware of this issue, let's go back to timeline step 8 and revisit the result of relying on trending to forecast the impact of future deployments. Even with a conservative projection, trending gave no prior indication of the risk of overheat. In conclusion, relying solely on monitoring is unreliable and can be misleading. Employing trending techniques can lead to availability issues. Thank you for watching this video. If you're interested in learning more, please continue to view the rest of the videos from this series. If you would like more information, please feel free to contact us.